Alright, so we have 2 cosine theta minus the square root of 2 equals 0. And we want to find all the values of theta on the unit circle, 0 to 2 pi, that satisfy us. So very first thing, before I start looking at any angles or anything like that, I have to get the trig function, cosine, all by itself first. So I'm going to add the square root of 2 to both sides. I get 2 cosine theta equals the square root of 2. And divide both sides by 2. And I get cosine theta equals the square root of 2 over 2. Now that I have my trig function all by itself, this is when I would go to the unit circle and look at where does this occur. Where is cosine of theta equal to the square root of 2 over 2? And we should get that theta is equal to pi over 4 and 7 pi over 4. Only 2 places that it happens. I'm restricted to the unit circle. So there we go, I'm done. Okay. Alright, so let's do one more example. One more. So let's say I have Alright, so I want to find all the values of theta in the interval 0 up to 360 degrees. So again, I'm on the unit circle, but this time, how is it different this time than the last example? I'm in degrees, so my answer should be in degrees, right? So this little interval tells you lots of different things. So it's in degrees, my answer should be in degrees, and I am restricted to the unit circle. So before I start doing anything, I need to get my trig function by itself. I have this 2 on the outside, so I need to get rid of it by dividing both sides by 2. So I get sine of theta is equal to negative square root of 3 over 2. My trig function is all by itself, so again, go to the unit circle, find where sine is equal to negative square root of 3 over 2, and I'll get theta is equal to 240 and 300. Just by looking at the unit circle. Okay. All right. All right, so let's expand that a little bit. Yeah, we always got to, right? All right, so there's our basic trig function. Now let's add a little bit more to it. Let's say I want to solve 2 cosine of 2 theta plus the square root of 3 is equal to 0. I want to find all possible values of theta. I no longer have an interval, which means I'm no longer restricted to the unit circle. Right? No longer restricted to the unit circle. So I want to find every single value possible, looping around the unit circle as many times. So very first thing, I have stuff on the outside. I need to get my trig function all by itself, so I got to get rid of it all. So I'm going to subtract square root of 3 from both sides. And divide both sides by 2. When I divide by 2, I'm getting rid of the 2 on the outside. The 2 on the inside, just ignore it for the time being. Okay? 2 on the inside, just ignore it for the time being. I have cosine of 2 theta equals negative square root of 3 over 2. Now, cosine of 2 theta is an angle, regardless if there's a 2 there or not. And I want to know what is that angle. What angle causes cosine to be negative square root of 3 over 2? I have my trig function all by itself, regardless of what's on the inside. So now is the time to go to my unit circle and figure out for what angles is cosine negative square root of 3 over 2. 7 pi over 6. Alright, so I'm going to draw me a little unit circle here. Cosine is negative, so I'm going to be on the left over here. And so we have 7 pi over 6. And where else? 5 pi over 6. Right, these two values. The distance between my first and my second is definitely different than the second and the third. So I will have two different answers. So I will have 2 theta, because that's what's inside my parentheses, 2 theta equals 5 pi over 6 plus 2 pi k, and 2 theta equals 7 pi over 6 plus 2 pi k. Now my task was to find theta. So I have 2 theta. How can I get rid of the 2? Just divide everything by 2, just like you would for any other variable. So I'm going to divide the left side and the right side by 2. Left side and the right side by 2. So for my first answer, 2's cancel out, and I get theta equals 5 pi over 6 divided by 2. We're dividing by 2, keep, change, flip, however you want to think of that. Dividing by 2 is the same thing as multiplying by 1/2. So 5 pi times 1 gives me 5 pi. 6 times 2 gives me 12. Plus 2 pi divided by 2 gives me pi. Okay. And then my second answer, same exact thing. So, and theta equals 7 pi over 6 divided by 2, 7 pi over 12, plus 2 pi k over 2 gives me pi k. Those are my 2 sets of answers. Alright, so we're going to do the same problem over again, but I'm going to restrict it to the unit circle, just to look at how is this going to change things. So, same exact problem. But I want to solve for theta in the interval 0 to 360 degrees. So I'm restricted now to the unit circle, and I'm writing my answers in degrees instead of radians. How about a 2 in here? 2 theta. Alright, so I'm going to solve it just like I did before. Subtract the square root of 3 from both sides, divide by 2. I get cosine 2 theta equals negative square root of 3 over 2. So I have 2 theta equals, we said 5 pi over 6, which is 150 degrees. And I'm still going to set it up the same exact way, even though I'm restricted to the unit circle. And 2 theta equals 7 pi over 6, which is 210 degrees. Now to get theta, again I'm going to divide everything by 2. And from the first set, I get theta is equal to 75 degrees plus 180 degrees K. And from the second, I get theta is equal to 105 degrees plus 180 degrees K. The problem asks for strictly the values of theta inside my unit circle, and so I'm just going to figure out which of these answers are still inside the unit circle. So remember what k is. It's any integer. So negative infinity to positive infinity with just the whole numbers. So k could be 0. Right, I don't want negative because I still just want to be inside my unit circle. So I'm going to start with k being 0. If k is 0, I get 75 plus 0, which is 75. That's definitely in my unit circle. If k is 1, I get 180 plus 75, which gives me 200 and what? 55? Is 255 degrees still in my unit circle? Yeah, it's less than 360, right? If k is 2, I get 360 plus 75. Will that still be in my unit circle? No, because it's larger than 360. So I'm done with that. So I'll come over to the next one. I have theta equals 105 degrees plus 180k. So again, I'm going to start with k being 0. So 180 times 0 is 0 plus 105. So 105 degrees. And then k being 1. So 105 plus 180 gives me 285 degrees. And let's try one more. If k is 2, I get 105 plus 360. Is that in my unit circle? 185 plus 360 is in my unit circle? No, not at all, right? So anything larger than that will no longer be in my unit circle. So these are my 4 answers.